Finding area of triangles with sine. Consider a triangle drawn as follows. Maybe we know the base to be 10, this angle to be 25 degrees, and this side here to be, say, 21. As you look at the scenario, you're basically working with a side angle side scenario. And what you need is the height of the triangle, because you already have the base being 10. The height in this situation would be this auxiliary line that I draw to the outside of the triangle. So I have this height here, and this is the information I'm interested in. Now, if you are looking at this triangle, this right triangle, we know that we can set up our sine, and we can say that sine of 25 degrees would equal this opposite, which I'm going to call my h for height, over the hypotenuse of 21. And we've solved that numerous times in the past. Simply multiply both sides by 21, and you will have the value of your height. So I can go to my calculator and I type in 21 times sine of 25, and it gives me a value of 8.87. And as we spoke about so many times before, please make sure that you keep all your decimals in your calculator, otherwise your answer could have error in it. Now, to pull this all together, the area of a triangle is half the base times the height. If I wanted to do this in one straight shot with my calculator, I can say that the area is equal to half. The base in this picture was 10, so it'd be 10. And when I figured out the height, it was nothing more than the sine of the angle times the hypotenuse. So I'd say 10 times 21 times sine 25. This is coming from this line right here. That is what my h was, 21 sine 25. Now I can plug that all into the calculator. I simply go 0.5 times 10 times 21 times sine 25. And that gives me an area 44 point, we'll go 3 decimal places, 375 for this video. And that would be units squared. Now, as we continue with this, some of you may look on the internet and you'll see that they have a formula that it says the area is equal to the base, whatever your base is, times half the sine of the angle times your hypotenuse, kind of like what I just went through. You can use that 1/2 AB sine angle is what they'll tell you. You can use that formula, but I really want to make sure that you understand where this is originating from and why it works. So what I want to do here is draw a couple of these triangles and show you a phenomena that's going to go on here. Because not every triangle will look like the original one that I started with. Not every triangle is going to look like this. You could have a triangle that's drawn out like this. Maybe this is 30 degrees. And we have this base value being, oh, I don't know, 55. And let's say that this hypotenuse is 7. Oh, better be more than that. Let's go 37. The part that will remain the same is you do want to drop a perpendicular. sometimes that perpendicular, sometimes that altitude or height of your triangle will fall inside the triangle. Sometimes it'll fall to the outside. It is what it is. Now this height is never going to change. It's always going to be, to find this height, it's going to be sine, which would be opposite over hypotenuse. So if I say sine of 30 degrees is equal to opposite, which is h in this case, over 37, I can bring that 37 up, and I have a value for my height in this triangle. And I simply take that idea and I'm going to plug it right into the formula for the area of a triangle. Area is equal to half the base times the height. So my area would equal half. The base in this case is 55. And the height is what I just calculated here, is that 37 sine 30. That's why when you look up on the internet and they just give you a formula, I've always told you guys, I don't live and die by formulas. I want to be able to think and realize what's happening. That's what they're saying here. Half each of the sides and then sine of your angle. That's what's happening here. I got half of my base times the other side that I was given, and then sine of my angle. And this is a scenario where it's side, angle, side. So I always determine what my height is and then work off of that. Now I could throw this into the calculator. It'll only take a second to do. So I go 0.5 times 55 times 37 times sine of 30. And I get 508.75. Let's look at a third scenario. Let's look at a wild triangle drawn like this, where they give me lengths that are 43, 49, in an angle that is 103 degrees. Really nothing would change here. I am going to draw the height of the triangle and rework the idea here. If I drop a perpendicular here to be the height of my triangle, what I'd be interested in is this angle right here. And because this is a linear pair, I can take 180 minus 103, and this would give me 77 degrees. Now before I get too far along, I want to show an idea here that is unique to the sine. So I'm going to clear my calculator out. We're going to step away from this problem just for a second. Watch what happens if I take, say, sine of 10 degrees. I go sine 10, and I'm getting this 0.17, 3648, so on and so forth. If I take sine of 180 minus 10, which would be 170 degrees, so I type in my calculator, sine of 170, I get 0.1736. I get the same value. In the scenario that I just plotted out, if I take sine of 103, I get 0.9743. Or if I take that supplemental angle, that 77, and I go sine of 77, I get the same value, 0.9743. You'll learn more about this when we get into a unit circle later in the year. You'll see why this is happening, why this is true. But for now, what you need to know is that if you take the sine of an angle and the sine of the supplement to that angle, you will get the same result. Which means when I am looking at this and I want to do that sine idea for my altitude, for my height, the height is going to be the sine of 77 degrees which is going to be equal to, let me rewrite this part here, the opposite, which would be the height, over that hypotenuse for this red triangle, which was 49. That 49 actually belongs over here. I simply multiply by 49, and that would be my height. But notice that this 77, as I mentioned a moment ago, I could replace that with 103. You could go either way. You're going to get the same answer. So when we're using this formula, we can say that our area is equal to half the base. Now the base in this triangle is 43 degrees times the height, which would be the 49 times sine. Now I can go either way. I can go sine 77, or I can use that original 103. It's going to get the same result either way. Sine 103. I like to use original information whenever I can. And so in my calculator, I say 0.5 times 43 times 49 times sine 103. And this gives me an area of 1026.499 units squared. Now, the only other thing that you can see in your problems as you work through a series of questions tonight for homework, maybe they'll give you the triangle oriented in a different way. So maybe they put it over here where they say that this is 103, this angle is 13 degrees, and this entire length down here is 256. It doesn't really change anything. Or maybe they completely redraw the triangle. They tell you that this is 97 degrees, and this is 41 and 32. It does not matter, because you could always rotate. You could always rotate the triangle to get it into that orientation. What you're looking for is that you have that side angle side. And so what we're walking away with is we now have yet another way to find the area of a triangle. The area of the triangle, when you have side angle side, will be nothing more than taking half your base times your height, where your height is going to be that hypotenuse, so whatever your hypotenuse is, times the sine of the angle. So maybe in this case you're going to go, when I draw that triangle like this, my angle that I'm interested in is when it comes down like this. This is my hypotenuse, is that 41. So I could say 41 sine 97. That's what gets placed in there. And so then for my area for this strange triangle that's drawn up here would be area is equal to half the 32, that would be what I designate as my base, times 41 sine 97. And after you set a few of these up, you realize that the concept is pretty easy, but I want to make sure you understand where it's coming from and why it works. Okay, so it goes back to the concept of sometimes your altitude's on the outside, sometimes your altitude's on the inside, and you're really always going to use that given angle, and it'd be the sine of that given angle. And you just need to know who your hypotenuse is and who your base is. So there's our example of how to find areas of triangles using sine.